Okay, so what these polylines are actually going to become is going to be like an axis for each panel. And okay, so first of all, we want to think about how can we use those polylines now to start to define individual panels. So what we're going to do is we're going to explode those. When we explode those polylines, we end up with lots of little lines in between. And again, we're going to use that flip matrix. So if you think about it now, each polyline has been exploded. This one's been exploded into 2 pieces and the other's into 5, and you can see that here. And then the very last one, which is the one that couldn't be created, is in 0 pieces. So that could cause us some problems, but we're going to clean it up. So we're going to flip that matrix again now, so that we're going to reorganize these lines into each bay. Each one's got 34. Now if we have a look at one of those, let's right click, simplify that, and let's pull out a single branch from the data tree. So that's going to be, let's just grab the first branch and let's have a look in a panel how that works, how that data is organized. You can see it's line like curve, 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 and then null. Okay, so we got something that's not very useful here. So if we try and loft through those, and it's going to throw us an error because it says, yeah, there's something not there, not right. So what we can do is there's a little component called clean tree. We plug this in here. Let's just see what we get with the result. So that's actually taken out that null. So what we can see here is now our lines are nicely organized running through here. So this allows me to just pick different ones, and you can see that they have different numbers of line-like curves. So let's just bypass the branch because we want to work with all of them. Let's clean all of those up, and so now we get these lofted strips. So what I've got to here is already we've got quite a good model, because this, if I bake this lofted, or first of all, if I change the loft options to straight, not uniform but straight, commit that. Now if I bake this into Rhino, so I just have to check the command for unroll surface because my Rhino is currently in Spanish here. So I bake that. You can see now these are strips of panels. If I put in, it's in Spanish, it's desplegar superficie, descomponer, no, see what we get. So this is quite cool because now we've actually got a system here that we could laser cut this, and that would give us a way of making a physical model. So right there we've got quite a nice potential model that we could actually build. So I'm not going to do that right now because we want to go a little bit further, get in a little bit deeper. So I'm not really interested in lofting those just yet. I've got them nicely structured, and the next thing I'm going to do is I'm going to take the sublist component again, and I just want to think about the facade. So with the stadium somewhere around here, which corresponded with the back of the seating, there was a distinction between roof and facade, and I'm just going to make that distinction by looking at, let's get the maximum number of pieces, length. So check the length of those lists, and I want a domain again like we made before. So because this is length and we are talking about the indexes, in B we need to do x minus 1, so that gives us the index of the very last piece, and we need a bit more room. The slider, let's just give it the value of 12 to begin with. So I'm very deliberately making my job easier and easier by making the part of the building, which is why it's so important to reduce the scope of your study right the way down. So now you can see here that I'm sub-selecting down to around here somewhere. So in the Aviva Stadium, the type of panel actually changed, and through here there was a gutter that collected water from the roof before it became the facade. So we're really thinking about this as being a very specific facade study. So I showed you images of this model just to put this in a bit of context. This is exactly how we produced the data for this model. So we took our parametric definition of the surface, extracted a series of bays, extracted the parts, thickened them, defined tube sizes, parts to be 3D printed, and this was the result. So this was a way of testing that fabrication process. So we're doing a kind of slightly simplified version of exactly the same thing. So back here in Grasshopper, we the next step is now to think about, we want to make planar panels. So we need some way of defining one plane per panel. So what we've got here, let's just hide this, and let's just hide this and the polyline so we can see what's going on here. So what we want is some kind of point referencing system. So onto here we can put point on curve, just the quickest way to give us a point on the curve, and that's going to be the origin of each panel. So we also want another subset which is going to start one before and stop one earlier than our set here. So what I'm going to do is make a copy of that. Also I need a copy of the domain. Put that domain in there. Right now it's exactly the same. So I said we're going to start one sooner, so that's x minus, and then here x minus 2. So right now you can see this one starts here and ends here, and we're going to do exactly the same. We've got two sets of points, which now gives us a way of creating a line which is going to start from this one and go to this one. So that line could be a vector, but we get an immediate visual representation. And so we want to make a point from plane, construct plane. So we've got information about the axes, we've got the line that runs across, we've got the small line. The origin is these points here, and the x direction are these lines, and the y direction are these lines. Now you probably see here, oh yeah, we can't see, oh there we are, can't see the planes, but there we go, we've now got one plane per panel. So this is going to be the axis of our first panel through here, and we'll continue in the next video.